So again, let's try something similar to previous problems we've seen. Let's try to find all theta such that tangent of theta is equal to a quarter. Let's start off with a unit circle as always, because it's very hard to wrap your head around this unless you have a clear image of what this means visually. So let's draw a unit circle, or attempt to. Very good. Now, same old story. Tangent represents what? It represents the slope of an appropriate straight line. So given an angle, theta, it gives a position on the unit circle. And tangent is the slope of this line. So what are the possibilities? We've got tangent of theta is equal to a quarter. That means the slope has to be a quarter. So that means, for example, if you're over here, it would have to be fairly low like this. But there's another position, or one more position on the unit circle, which has the same slope, namely over here. Is that even straight? Just about, namely over here. So there are two positions on the unit circle which have that. So what do I need? Well, basically, I need to have this. I need to have the smaller angle, right? That would be a really useful thing to have. So what I want is my kind of angle in here. So let me attempt to kind of draw this in. So let's call this angle, let's call it theta, shall we, right? So I need to know theta. That's what I need to know. In fact, I won't call it theta because that confuses it. I need to know, let's say, alpha. Let's write that. So my choice alpha here, first of all, it's in the appropriate, it's in this side, right? So let me, it's on this side. So by my construction, what do we have? Well, theta is in the appropriate restriction of the tan function for the arctan. It's in here. It's on that side. And I'm assuming that tan of alpha is equal to a quarter. So what does this mean? Well, this means, by definition, arctan of a quarter is equal to this alpha. Right? It's that alpha. It has to be that one because it's got to be the angle which is in the appropriate range. So then what? Well, now I need to describe every other position that could give tan of theta is equal to a quarter. And that's same as before. It's all half revolutions away from alpha. So tan of theta is equal to a quarter if and only if this is equal to, well, alpha plus some integer number of half revolutions. So something we've seen before. Okay, but now this is equal to what? Well, I've got something pretty concrete. This is arctan of a quarter plus k pi. So that's all possible values. So you've got to really understand the arctan function here. And you may think, why am I doing it with the arctan function? The basic reason is a quarter isn't a special value. If this was one of my kind of special values, something like root 3 divided by 1, for example, that's, for example, the tangent, I think, of pi over 3, then you might have something more specific. But there's no, this alpha isn't some kind of magic number, not one that's obvious anyway. So we have to use the arctangent function to write this down.